Our today theory lecture is energy interaction with Earth surface. When sunlight or any electromagnetic radiation fall on the Earth's surface, the radiation can be reflected from the surface. The radiations can be scattered from the surface. The scattering can be more from a rough surface. The reflection will be more from a smooth surface. The radiation can be transferred through that object. The radiation can be absorbed and emitted afterwards at any time when there is temperature difference. So we have to study, we have to focus the interaction of radiation with water, soil and vegetation and so on, like clouds, like snow, water. So we will see in our different practicals using equations, using algorithms like water NIR interaction, like water shortwave interaction. So radiation occurs when radiant energy bounces off the target and is thus redirected. Not all solar energy is reflected. सारी की सारी जो solar energy है वो reflect नहीं होती, but there is some energy which is transmitted to that body and so on. So here you can see we have a flat body and here we have a irregular surface. The scattering is more in this surface and you can see this surface is smooth, and specular reflection, mirror like reflection, which is like this one. Specular reflection, if there is smooth surface, these angles will be equal and reflection will be more, and the data will have more and more brightness or digital number or transfer to its sensor. Second one is diffuse reflection, which is reflected in multiple directions. So the spectral reflectance curve, it is also called as spectral signature. What is a signature? When you make your own signature, it means that is specific to you. So it means when electromagnetic radiation interacts with any earth feature, then it means individual earth feature shows a different type of response to different type of wavelength. It means they have something, there is nothing common, they have something special for every earth feature to every electromagnetic radiation. For example, water will reflect a different response to NIR and different response to visible and different response to shortwave infrared, midwave infrared. And the response of water to these 4 and 5 or any multiple radiation will not be observed from soil, will not be observed from snow, will not be observed from vegetation. The response of water in each electromagnetic band will be specific to water. Similarly, the response of vegetation cannot be offered by all the other earth features like water, like sand. Similarly, the response of snow will not be similar to the vegetation, will not be similar to water, but there will be little bit common in water and snow and clouds. We can differentiate using multiple equations, and we will do in different practicals. So the concept of spectral reflectance curve can be used to estimate the overall reflectance in different bands, measurements in reflectance, laboratory experiments. So first of all, and we will focus on spectral response or spectral signature in our different practicals, but you should have basic understanding of this lecture as we are going to do. This is the spectral reflectance curve of vegetation. I want to get your attention here that the reflectance characteristics of vegetation depend upon the properties, leaf size, the water moisture content in the leaf, the temperature in the leaf, the color of the leaf, orientation of the leaf, density of the leaf, canopy and structure, and many more. So the amount of energy reflected for a particular wavelength depend on leaf pigmentation, thickness and composition. So these are more agronomic and physiological structures. So if we see the visible band which is starting from 0.4, so this graph is starting from 0.4 and 0.7, here we have 0.7, I mean to say 0.68 or theoretically 0.7, where red band ends and near infrared band starts. So if we see the vegetation curve, there is a little response in blue band, and from blue to green the response, I mean reflectance is what we see in plants. You go to outside and just note the color of trees, plants, you will see most of the plants, 99% of the plants with green color. Why? Because the blue light has more chlorophyll absorption and reflection will be less. Green light absorb chlorophyll, but it absorb chlorophyll less as compared to blue and red. And I mean to say the chlorophyll has the chlorophyll which is present in the plants, it has the capacity to absorb more blue and more red light and absorb less green light. So the reflection in green light will be more. You can see the graph, less reflection in blue, high reflection in the green, and then again less reflection in the red. So we observe these three visible colors. So if you see this graph from 0 to 0.7, you can see the reflection is more in green band. So that's why we see the plant green, due to chlorophyll pigmentation, due to chlorophyll pigments. So what happens in NIR? We cannot see the NIR from our visible eye. We have to go to instrumentation like green seeker, like satellite, like sensors. So we need NIR. NIR mean near infrared. Near infrared mean the portion of infrared which is very near to red band. So this is NIR. I hope so. It is from 0.7 to 1.3. Up to this point we have NIR. You can see its exact value from NASA website. I hope so. It is similar to 0.7 to 1.3. So you can see the leaf reflectance is more in NIR band. Leaf reflectance is more in NIR band, and leaf reflectance is less in red band. So we can make the formula normalized difference vegetation index. We will study in practical NDVI, normalized difference vegetation index, that is equal to NIR minus red over NIR plus red. I mean to say reflection in NIR minus red divided by reflection in NIR plus red. So why that equation? We have made that equation because NIR has higher reflectance and red has lower reflectance for vegetation. So that's why if you see beyond that value, there is a little reflection in 1.4 and again there is a rise and again fall and again rise. So in this band you can study the vegetation. From this to this band you can study the vegetation by combination of any visible band like blue or red. So this is an idealized spectral reflectance curve. Each crop will have different spectral reflectance curve in different seasons. Like wheat crop, it will show maximum NDVI, maximum green color in start of February, rice crop in August or September and so on. So cropping season matters, the month of crop, the vegetation density in any month, these all factors depends upon when you do some analysis. Next we have its theory. You can study, I have explained this theory. And next we have spectral reflectance curve of bare soil. We will also discuss this theory in our practicals when we apply NDVI, when we use NIR and short wave infrared, and we will see the difference. Next we have spectral reflectance curve of bare soil. So we have different type of bare soil, like A, organic soil, organic dominated. Second, B, minimally altered, there is no changing, no pulverization. Iron altered, organic affected, and iron dominated. So these are different types of soil. So you can see the main point and I think this is the heart of remote sensing to understand the spectral signature, because what I know from my experience, study or research, if you are good to understand the spectral signatures or spectral response of different earth feature, atmosphere, interaction of energy with atmosphere and earth, I mean to say, then you are the best person in remote sensing. If you have the concept that electromagnetic radiations are coming to earth and what is there, and if you are sitting in International Space Station just 340 kilometers above the earth's surface and you are revolving the earth about more than 90 times in a day or in 2 days, then you can see the response only from different parts of the earth. You can see the response. So you should have the basic concept, like the highest response is in B type. B, what is B? B is minimal altered soil, the soil which has not been altered, it is as its physical composition. So this soil has the response, rising response from 0.4 and has highest response in 1.2 micrometer, I mean to say in NIR at this point. So at 0.7, I mean to say at this point in the visible band, the response is less, but you can see all the soil has increasing trend. If you draw a line at this point, I mean to say 0.7 at this point, then you can see all the soil has rising trend, all the soil has minimum reflection in blue band, little bit higher reflection in green band, and highest reflection in red band. So if you see that soil type E, its response is, when we have here we have NIR at 0.7, when NIR starts, its reflection decreases. So from satellite, if we get, or at International Space Station, if we get this response, then we can understand what is this soil type there, that is iron dominated. So in this way, the minerals exploration process is going on with many satellites, like Advanced Land Observation System. You can open that satellite and similar other satellites. So they have the NASA and the advanced countries which have satellite, they have done thousands of experiments in their labs on different type of soil: iron dominated, nitrogen dominated, carbon dominated, calcium dominated. So they perform experiment, they develop their spectral reflectance curves, they have a good understanding of their spectral signatures. So when they get any satellite image, their scientists get idea that what type of soil, what type of minerals are there. So this is very important lecture of spectral response curve. If you see the response curve of A soil, organic dominated, its response is little bit lower, but its response is higher after mid of NIR, and its response is highest at the end of NIR. So if we see such similar response, that will be organic dominated soil. So this satellite, from satellite you cannot view the soil, its composition, but from algorithms, from concept, from equations, from thresholds, like this is threshold, at which band the value increases, at which band the value decreases. So the bands mean, if bands are more narrow bands, then you can get more understanding of this. So next one is, here is also explanation of that. So here we have water, we have ocean water A, we have turbid water B, and we have water with chlorophyll, water with many plants, like a lake which is full of plant, which is full of water lettuce plants and so on. So in this we have, if we see the A curve A, its response is highest in blue band and it is suddenly decreasing. It means it has less reflection in green band, it has less reflection in red band, but it has highest reflection in blue band. So that's why from Google Earth or satellite you see the ocean as blue. And we can see the B turbid water. The B curve has highest response in has highest response, I mean to say blue has high response, green has higher and NIR, and red has also higher. So that's why it has not any specific color. Its color also depend upon the sediment, reflection from sediments. And the third one is C with chlorophyll. It has chlorophyll, so it has little bit higher reflection in green band, I mean to say at here 0.6, and then it is decreasing at 0.7. And the most important thing, how to detect water bodies from satellite. The equation is here. I will say the equation is here. Scientists say that water absorbs NIR radiations and offers very little bit reflection. I mean to say, when we have water body in our lab, a water tank, and we spread NIR on that water body only on water body, the maximum 90% radiation will be absorbed in water. NIR radiation will be absorbed in water. Only 5%, 7%, 10%, and scientists say maximum 11% may be the reflection from satellite due to errors, atmospheric disturbance, and etc. You can see all the water types has minimum reflection at this point. After 0.8 there is a little bit reflection. You can see NIR is 0.7 from NIR start from 0.7. So there is reflection from 0.7, but at 1.2 the reflection is very low. So scientists build an algorithm that if NIR shows reflection less than 11%, then there is water. So the equations are in graphs. All the equations of vegetation, soil, the equations of vegetation are here. All the equations are here. The vegetation of every type of soil. If these are only 5 types, if we have all the graphs of all the soil type, then we can understand the behavior of the radiations. Similarly, the behavior of water.